go over worksheet number 2. I don't know what N-Q, maybe that's a section, maybe, but dealing with quantities. So we have a couple problems here. Let me grab my pen. And the first question says, your class is painting a mural. Working together, you can paint 20 square feet per hour. The wall you are painting is 10 yards wide by 3.5 yards tall. How long will it take you to paint the mural? So we have this mural. Let's make a rectangle. Let's give it some color. Not too, let's make it relatively, that's the line color, we'll leave that black. So we've got this mural that is 10 yards wide, 3.5 yards tall. That looks about good. That's 10 yards by 3.5 yards. And how long will it take? So when we notice that we're working in yards here, and then I paint in feet per hour. So I'm going to either convert it now or later. I will tell you that in order to not make a mistake, it is in your best interest to convert the units to feet now. There are more complications when you are provided a unit in square yards, converting it to square feet. There's lots of places to make mistakes. You have to do it exponentially, but we'll go into that. So 10 yards, we know that there are 3 feet in a yard, so 10 times 3 would give us 30 feet. And then 3.5 times 3 would give us 10.5 feet. So if we want to find the area, is going to be length times width, and so our area would be 30 times 10.5, which would give us 315 square feet. Now, that's the area of this mural. And if we paint at 20 square feet per hour, we would have 315 divided by 20, which gives us 15.75 hours. So if we wanted to see how long it would take us 15.75 hours, or 15 hours and 45 minutes. Good? All right, either answer would be acceptable depending on if they say give the time in hours. I think that's pretty much it. Number 2, to mix the paint for your mural, you are making orange paint by mixing 3 parts yellow paint, 1 part red paint, and 1 part white paint. You have 5 liters of red paint, and realize that you will need 2 gallons of orange paint. Do you need more red paint? So we again see that we have liters going to gallons, and then we actually have a parts. So let's see. Orange consists of these parts: 3 yellow, 1 red, and 1 white. Okay, and that's a total of 5 parts. And that's how you make orange. So that is the orange ratio. So this is to make orange, needs to be in that color ratio. Orange. All right, so the question is if we have gallons. So let's do gallons. So if we have 2 gallons, what is the proportion? Well, it's going to be, yellow is 3 of 5 parts, so we would take 3/5 times 2, which means that we would have 6/5 of a gallon for red, or for yellow, sorry, this is still yellow. And red would be 1/5 part of those 2 gallons, or 2/5 of a gallon of red would be needed. And white is going to be also 1/5 times 2 gallons, gives us 2/5 of a gallon. So if we added these up, 6/5, 2/5, 2/5, we get 6, 7, 8, 9, 10, 10 over 5, or 2 gallons, two parts. So this is the ratio of gallons. So I would need 2/5 of a gallon in order to produce a yellow, or 2 gallons of orange, of orange. And so it wants to know, do I have enough red? So I have 5 liters of red, does 2.5 gallons. So if I'm going to convert that to liters, it told me that 3.85. So I'm going to do my conversion, and I'm going to have 1 gallon in the denominator in order to cancel my G in the numerator. And that's going to be 3.785 liters in the numerator. 2/5 is equal to 0.4. So let's do 0.4 times 3. What's that? 3. Did I do the point? 0.785 gives me 1.54 liters. So that equals 514 liters. So I need 1.5. I have 5 liters, so I have do I need more red paint? No, I do not. No, you do not need more red paint. I have more than enough red paint. If I have 5 liters, all I need is 1.514 liters in order to make 2 gallons of orange. So we have these conversions that we're going to utilize. Good. Number 3. Let's take a look at that. It says, what needs to be correct in the following graph in order for it to not be misleading? All right, well, there's a lot of things missing. When we have this chart, it typically looks like that. One of the things is we have to make sure that this spacing between these intervals are even, and that's probably 1, that this spacing also, that's 5, 7, 9. Ooh, that's an interesting, so that doesn't look like very good spacing. So this probably is not pretty good, because what needs to be corrected, in the following. Well, I think the spacing here needs to be evenly. These need to be even spacing, so I would fix this part. It's missing units. I don't know what these units are. Is this 30 watt? What are these? And what are these units? So I need to know, what are we measuring on the x-axis and the y-axis, or the horizontal and vertical axes? And then you also need labels. I need to know what not only is the units, but we need to label what each of those axes are measuring. So those are 3 things: evenly spaced, I need labels, and I need units. That's going to help me know whether it's misleading or not. Number 4. All right. The highest speed limit in the United States for expressways is 85 miles per hour. In Vietnam, the highest speed limit is 120 kilometers per hour. Which country has a higher speed limit? So we have to choose. Are we going to convert to miles per hour, or are we going to convert to kilometers per hour? So I'll do each of them. I will do both of them. So let's first take the American unit, which is miles per 1 hour. And we're going to convert. We're going to have a conversion box. And we're going to have to utilize, I want to convert it to kilometers. So I know that 1.609 kilometers is equivalent to 1 mile per hour. I put the 1 mile in the denominator because I need to cancel it in the numerator. So I'm out of miles, and now I'm in kilometers in my numerator. So 85 times 1.609 gives me 136.765 kilometers per 1 hour. That's good. Okay. So we could make that assumption right now. We can make that determination. Should I say which country has a higher speed limit? That would be the United States. 85 miles per hour is equivalent to 136.765 kilometers per hour, which is faster than 120. The other thing I can do is I can take the 120 kilometers per 1 hour. That's not hour, per hour. And I can convert it. This is a value of 1. So we know that 1 mile is equivalent to 1.609 kilometers. This time kilometers goes in the denominator because it has to cancel with the 1 in the numerator. Now notice that when we multiply those, we get 120 miles, because that's what we're left with in the numerator, over 1 times 1.609 hours. Now this is not a unit rate, so we cannot compare them at the moment like this to this, because this is per 1 hour, this is per 1.609 hours. So I'm going to need to convert that to a unit rate. So I take 120 divided by 1.609, and we get 74.5804 blah 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 per 1 hour. So now we know that this is smaller than my 85 miles per hour. So this is miles per hour in the numerator on that one. So that works. Both of them corroborated. That's a tough word. All right. Prerequisite skills, unit conversions. Cat, the caterpillar, is 8 centimeters long. Express her length in millimeters. Okay, so we're going to go to millimeters, so we need to remember this fun little thing. King Hector died, unfortunately, drinking chocolate milk. This is kilometers, hectometers, decameters. This is meters, that's our unit. Our unit is meters, decimeters, centimeters, millimeters. Deci, centi, milli, these all have I's. That's how I know the difference between these two D's. That's deci. This is deca. So very important to know our units and what our letters require. So we're converting to milli. So we start with 8 centimeters. So we're starting in centi and we're going to milli. This is not milli, that is meters. Milli is over here, so we're going to move 1 place to the right. My decimal is 1 place. Sorry, my decimal here is 1 place. I'm going to move it 1 place to the right. And if we move it 1 place to the right, we get 80 millimeters. So 8 centimeters equals 80 millimeters. Cool. Let's do B. King Hector died. That's a horrible U. Unfortunately, drinking chocolate milk. My unit is meters. I start in centimeters. So I'm starting in centi, and I'm going to meters. So this time I'm going to move the decimal point 2 places to the left. So if my decimal point is here, 1, 2 takes me there. And that would give me 0.08 meters. So that decimal point goes there. That's how I got that value. Now, King Hector died, unfortunately, drinking chocolate milk. I'm starting with 8 centimeters. And this time I'm moving to kilometers. I'm way over here. So I start here. I go 1, 2, 3, 4, 5 places to the left. Decimal point starts there. And I'm going to go 5 places to the left. Oof. Did I put the unit on the last one? Yes, I did. Meters, good. So well, we're going to run out of space. So let's write that. 1, 2, 3, 4, 5. Fill in those gaps. So we get 0.1234 kilometers. So 8 centimeters is equivalent to tens, hundred thousands, 10,000, 800 thousandths of a kilometer. And part D, inch. Wow, inches. You trickster. We're going to have a conversion box. I'm going to have centimeters in the denominator to cancel with the centimeters in the numerator. And I need to find a value, an equivalency of centimeters to inches. 1 centimeter is equivalent to 0.3937 inches. If I multiply centimeters in denominator, cancel, leaves me with inches, and I get 3.1496 inches. If I need to round to the tenth, I get 3.15 inches. If I needed to round to the, that's to the hundredth, sorry. If I needed to round to the tenths, it would be 3.1 inches. If I needed to round to the whole number, it would be 3 inches. Lots of fun, different questions. Read and make sure that it doesn't give you a rounding value. Sound good? All right, awesome job.